about antiderivatives that I found that I thought was a little bit helpful. This is just a description of the antiderivative. It's the name we sometimes but rarely give to the operation that goes backward from the derivative to the function itself. Since the derivative does not determine the function completely, because you can add any constant to your function and the derivative will be the same, you have to do something later with the explicit function, but we'll worry about that later. Usually, we talk about an integral when we're talking about the antiderivative. And the definition of an integral is the area under a curve, which is the whole point of finding an antiderivative. But before we can get into any of these integrals, you have to practice taking some antiderivatives. So read through this sometime. You can pause this and read it, and then you can try some. And then, again, you just check your answer by taking the derivative and seeing if you get what you started with. So, back to the ones that I sent you. Oh, that's not what I meant to push. Where's my focus? Okay. So, the first one you had to do was 6x, and hopefully you see that the antiderivative of 6x is 3x squared plus c. Again, you always have to add the plus c because there are infinitely many functions whose derivative is 6x. 3x squared plus anything gives you a 6x, so you have to have that plus c there, or unfortunately it is wrong. For 838, I did 1/8 x to the 8th. Basically, the rule is you add 1 to the exponent and multiply by the reciprocal. That usually works. There are some cases that you'll see where it won't work. 839, you can see the answer there. I'm just going to go through these quickly, except for the ones that are a little bit tricky. 840 was no big deal. 841 wasn't so bad. 842 wasn't so bad. 843, again, anytime you can write something with a negative exponent, do so. So 843 is this one, so I just wrote the x with the negative exponent. The next one, though, 844, was really tricky because I started to do it using, as you can see, a negative exponent. But when you have something to the negative 1, its integral is the natural log, because the derivative of ln of x is 1 over x. But then we have this complicated function in here, and I got thinking, that doesn't really make sense. I don't really want to deal with that. So then I went back and realized I could rewrite 1 over 2x cubed as 1 over 2 times 1 over x cubed, in which case the integral would be, the function could be rewritten as a half x to the negative 3, and then the integral, or the antiderivative, would be that. So I hope that makes sense. That was the first one that was pretty challenging. The rest of these you can just check your answers. Again, secant squared, you just have to remember that the derivative of tangent is secant squared. And then for the next ones, you just have to do the backwards chain rule. So basically, what was I going to multiply by when I took the derivative? And let me multiply by the multiplicative inverse, or the reciprocal, so that that will go away. So then we get to, where were some more tricky ones? There's 850, 851, 852. 854 was hard because I totally forgot that 1 over x squared plus 1 is the derivative of the arctangent, and you just have to remember that. That's the bottom line. You still have to have those memorized. So there's your answer to 854. And then 855 wasn't so bad. That's here. And the answer to the last one is choice E, and we can talk about that if you'd like. But if you struggled with these, let me know. I can find you a whole bunch more to take antiderivatives of, but you have to be able to take an antiderivative. Okay?